Okay, everyone. Let's dive into lecture. So I just briefly want to talk about what the format of the lectures is going to be this quarter. So I'll start each day of lecture with learning objectives, and then I will have slides that I'll go over that are posted on Canvas. These slides will have definitions on them, for example. I'll go through these quickly because you can read them for yourself and also in the textbook. What we'll spend time on is how to use the definitions. There'll be figures we'll look at and annotate, and then we'll be doing practice problems as well. I will demonstrate how to do practice problems, and then there'll also be time for you to work on them. So starting today, we are in Chapter 9, Energy, Enthalpy, and Thermochemistry. You should be reading sections 9.1 to 9.5. And our learning objectives are defining the system, the surroundings, and the universe, talking about different types of systems, open, closed, and isolated. We'll describe energy and energy transfer. Energy transfer is work and heat. Recognize gas expansion and compression as PV work. We'll state the first law of thermodynamics, both in words and mathematically. And if we have time, talk about heats of reaction and calorimetry. So starting with some definitions. The system is the part of the universe that is our focus. It's what we care about. The surroundings is simply everything else. The universe is the system plus the surroundings. So let's say we have a system here. Everything else around it is the surroundings. Okay. And between the system and the surroundings is a boundary. We'll talk about three different types of systems. The first one is an open system. An open system can transfer energy and matter. Okay, between the system and the surroundings. An example of an open system would be us, or all living things. Okay, right? We transfer matter, we eat food, then we get rid of it the other end. We transfer energy as well. We're all radiating heat, right, to our surroundings. The next type is a closed system. A closed system transfers energy but not heat. Okay, so but not matter, excuse me, sorry, bleh, brain. But not matter, just energy. And the third type is an isolated system. An isolated system doesn't transfer energy and it doesn't transfer matter. I will do my best to pause and give you time to write. If you ever miss writing something, you could, of course, ask a classmate, but remember, this is all recorded. So you can go online and you can find everything in the videos if you miss anything. Also, if you have a question, please let me know, but I will also try to pause for questions. Okay. Now, energy is defined as the capacity to do work, which we're going to represent with the symbol a lowercase w, or to produce heat. And heat, we give the symbol lowercase q. Energy has units of joules. Now, there are different types of energy. There's potential energy. One you're probably familiar with is gravitational energy. So, for example, if I hold my water mug up here above the floor, right, it has gravitational potential energy. If I let go and I drop it, that's going to be turned into kinetic energy, right, as it slams into the floor. But I like my new water bottle, so I'm not going to do that. Okay. Another type of potential energy is chemical energy, which chemists care about a lot. That's energy in bonds in molecules. Now, kinetic energy, energy of motion, that includes things like mechanical energy and electrical energy, movement of electrons. Also, thermal energy. Thermal energy is from the motion of atoms and molecules that make up or comprise an object. Now, energy can be transferred from one form to another through work or through heat. The next slide I'm showing gives a nice synopsis of types of energy. So you're welcome to look at that if you want, different types of kinetic energy and different types of potential energy as well. But I want to move on to showing you this really cool simulation from PhET. During the quarter, I'll show a number of these simulations as they're relevant to our class. They're a lot of fun. There's a lot of simulations online for biology, for chemistry, for physics, for example. But this first one is about energy transfer. Okay, so we have this nice young lady on a bicycle, probably in Davis, wearing a helmet, good for her. And she's got a whole bunch of green E's in her body. So that is symbolizing chemical energy. She's had a good breakfast. She's eaten some food. Okay, she's got chemical energy. I'm now going to start her pedaling. When I start her pedaling, she's going to start taking that chemical energy and turning it into work to move the pedals and change that into mechanical energy. Mechanical energy is going to be given by these gray E's. Mechanical energy goes to this, basically this sort of like this, to turn this gear, I should say, it's really a pulley, to turn this pulley in this generator. The generator turns that mechanical energy into electrical energy in blue, which flows through the wire, and then goes to a heating element. Oh, now she needs to be fed. Let me feed her. Goes over to the heating element. This is like if you have a stove with those electric coils. Okay, so that goes to thermal energy. And now heats the water. You can see the temperature goes up, and eventually that water starts boiling. Okay, so this is really cool. You can see energy being transferred through this system through work and through heat. This is a lot of fun. You can also play with using water. For example, like water mills, like old stone mills, used waterfalls. You can also play with energy from the sun, captured by solar panels. Or if you want to go back to the Industrial Revolution, you can do like a steam train. You can make steam and make this move as well. Okay, so just to give you a feel for different types of transfers of energy. Now, when we're transferring energy through work or heat, we have some important sign conventions. When we look at the energy, our values are going to have a magnitude. So when I say a magnitude, I mean the numerical value. So 6 or 1,000, 300. They're also going to have a sign, a plus or a minus sign. That sign indicates the direction of the energy transfer. Okay? So don't think about a number line. Just think about that plus or that minus. It's just telling you the direction of the energy transfer. So if work is done on the system by the surroundings, the work has a positive value. If it's the other way, if the work is done on the surroundings by the system, it's going to have a negative value. Similar for heat. If heat flows from the surroundings to the system, it has a positive value. If heat flows from the system to the surrounding, it's negative.